Hello, today we're going to look at the probability of combined events. So that's where there's more than one thing happening at once. Now remember, when we're calculating probability, the way that it's worked out is as a fraction, and on the top of your fraction in the numerator, it is number of favourable outcomes. And on the bottom, it's total number of outcomes, or total number of possible outcomes. Okay, and we've seen in the last couple of lessons why that makes sense to work it out that way. Okay, so let's look at the first example. A coin is flipped twice. Find the probability of getting A, 2 heads, B, at least 1 head, and C, no heads. Okay, so to be able to do this, we need to work out how many different things can happen. So when we flip the first coin, we either get a head or we get a tail. Okay? When we flip the second coin, we either get a head or we get a tail. So it's possible that the first one was a head and the second one could be a head. But also if the first one was a head, the second one could be a tail. Then, if the first one was a tail, the second one could be a head. And if the first one was a tail, then the second one could also be a tail. So they're the only 4 possibilities for this. So the total number of outcomes here, so the bottom of the fraction, in other words, is going to be 4, because there's 4 different possibilities or combinations of flipping a coin twice. So, part A, the probability of getting 2 heads, remember we would write that down as capital P and then the event that we're interested in, or the question. So probability of getting 2 heads is going to be, well, let's just have a look here. That's 2 heads, that's not, and that's not. So there's 1 out of 4. So the probability of getting 2 heads when you flip a coin twice is a quarter. Okay, now part B, the probability of getting at least 1 head. Okay, well, let's get rid of that, it's in the way. If we think about that, at least 1 head, so that would be this one, because that's at least 1 head. That's at least 1 head. That's at least 1 head. That's not. So that, remember, is 3 out of 4, 3 quarters. And then part C, the probability of getting no heads. When we look through these, we can see that this one is the only one with no heads. Okay, so we say probability no H is 1/4. Okay, so the best way to do questions like this is to at least start to list the different outcomes. All right, question 2. A dice is rolled and a coin is flipped. Find the probability of getting all those different things. So a dice is rolled. So remember, when you roll a dice, you could get a 1, 2, 3, 4, 5, or a 6, and they've all got equal chance. Okay? Now, what we're going to look at for this one is called a probability tree, okay? So what we do is we start here and we say these are the things that could happen to start with, okay? So then we flip a coin. So each of these outcomes from the dice could be followed by either a head or a tail. So that's what we put onto the tree. Running out of space, aren't I? Okay, so at the end of each of these lines are all the different possibilities. So if we follow the first one along, it's a 1 followed by a head. And then following the second one, it's a 1 followed by a tail. Then the next one, to get here, you have to come along the 2 and then the head. And then to get to this one, it's 2 and then tail. So you see what I'm doing there. Okay, so we could keep on listing those all the way to the bottom. Okay, so let's look at these questions then. So part A, probability of getting a 6 and a head. Well, when we list all these, if we just keep going with it, we'd have 3H, 3T, 4H, 4T, 5H, 5T, 6H, 6T. So if we count all those up, we'll see there are 12 different possibilities here, okay? So the number that goes on the bottom of our fraction for probability, total number of possible outcomes is 12. And if we look, only one of them is 6 and a head, okay? So it is 1/12 for part A. Part B, a tail and even number. Well, let's have a look at those ones, see which ones they are. So a tail and an even number. So the even numbers are 2, 4 and 6. So the ones that are a tail and an even number are this one, and this one. There aren't any others that are a tail and an even number. So that's 3 out of 12. And like we were looking at yesterday, this fraction will cancel, will simplify, because 3 and 12 are both in the 3 times table. So dividing top and bottom by 3, divide 3 by 3, you get 1. Divide 12 by 3, you get 4. So that probability is 3/12, which is the same as 1/4. Then part C, a number bigger than 2 on the dice and a head on the coin. So let's have a look at the numbers that are bigger than 2. Now that doesn't include 2, by the way. If it's bigger than 2, it doesn't include 2. So the numbers that are bigger than 2, we're looking at from here downwards and getting a head as well. So that would be here, here, here and here. So that one would be 4 out of 12. 4 and 12 are both in the 4 times table. So that would be 1/3 when you divide top and bottom by 4. Then the last one, probability of getting a head on the coin. Well, just a minute, let's get rid of these. That is this one, this one, this one, this one, this one, and this one. So that's 6 out of 12, okay? Which makes sense because 6 out of 12 is a half, isn't it? So that makes sense because the probability of getting a head on the coin is a half, okay? Because that question doesn't rely on what you score on the dice at all anyway. Okay, got one more example to look at. So, an 8-sided spinner is spun and a primary colour is picked at random. So here's our 8-sided spinner. So it's got equal chance of landing on any of the numbers from 1 to 8. Okay, so first of all, find the probability of getting an even number and blue. Well, we need to work out how many different possibilities there are, don't we? So on the spinner, we've got 8 different possibilities. So we could get 1, 2, 3, 4, 5, 6, 7, or 8. And if we got a 1 on the spinner, we can get a red, a yellow, or a blue from our primary colours. And that's the same for every one of those numbers. So we could list all these outcomes. We'd be listing a 1 red, 1 yellow, 1 blue, 2 red, 2 yellow, 2 blue, 3 red, 3 yellow, 3 blue, and so on, right up to 8. In the end, it would be 8 red, 8 yellow, 8 blue. Okay, so it would have all those ones in between as well. So how many different possibilities are there? Well, if there are 3 for each of the numbers, and we've got 8 numbers, 3 times 8 is 24. Okay, so the probability of getting an even number in blue, so the even numbers are, just let me put this over here. The even numbers are 2, 4, 6, and 8, and blue, 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 blue. So there are 4 different ways of getting an even number and blue. Okay, so we were going to put a 4 there. Okay, so that will simplify both in the 4 times table. It gives us 1/6. So the probability of getting an even number and choosing blue is 1/6. Okay. Part B. Probability of getting a 2 and red. Well, we can see here is the probability of getting a 2 and red. There is only one way of doing that. Okay. There's only one chance out of those 24, there's one outcome out of those 24 different outcomes that is a 2 followed by choosing red. So that's 1 out of 24. Okay. Part C, a number bigger than 4 and red. So the numbers that are bigger than 4 are 5, 6, 7, and 8. And followed by red. So there's only 4 different ways of that happening. So probability of bigger than 4 and red is 4 out of 24, like part A is 1/6. Okay. Part D, probability of getting a 9 and green. Well, there's no 9 and there's no green. So it doesn't matter really about the colour if it's probability of 9 and any colour or probability of green and any number. It's still going to be 0, isn't it? Because there's no chance of picking either a 9 or a green because they're not there. Okay. E, probability of getting a 5. Well, if we'd continued this list here, remember we would have written 5 red, 5 yellow, 5 blue. So there's 3 different ways of getting a 5, 3 out of 24, and 3 out of 24 simplifies both in a 3 times table to 1/8. Oops, dodgy 8 there. And then lastly, excuse me, I'll get rid of this, get some space. Lastly, a number bigger than 1 and any colour that is not red. So probability bigger than 1 and, well, it's basically yellow or blue, isn't it? Okay, so the numbers bigger than 1 are 2, 3, 4, 5, 6, 7, and 8. And the numbers that are not, the colours that are not red are yellow and blue. So we can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 different ways for that to happen out of 24. And they're both in the 2 times table. So we can divide top and bottom by 2 and get 7/12 for that last probability. So this one was a little bit more complicated because there was more to think about. But each time you get a question like this, if you write out, or at least start to write out, the different outcomes, then you'll spot the pattern and you'll be able to do it a lot more easily. Okay, see you soon.